right. Hey guys, so today we're going to do Unit 4, Lesson 17, and we're going to look at writing inverse functions to solve problems a little bit more. So in your warm-up question, you had a question about a tank that had some water in it. So the function W represents the relationship between T, time in minutes, and the amount of water in the tank in liters. The equation W of T equals 80 minus 2.5 T defines this function. So you need to remember that the W here in your function is just the name of your function. And then the T in parentheses tells you your input of your function, what you are putting into the function to get your output. W of T altogether is your output of your function. And so in order to solve this, 80 minus 2.5 T would give us the output, which we would be looking for would be the amount of water in the tank. So how is the water in the tank changing? Well, if you're dissecting this equation a little bit, you can see that it starts out with 80 liters and it loses, since it's being subtracted, 2.5 liters per minute, since T is in minutes. So that's how the tank is changing. So it's starting with 80 liters and it's losing 2.5 liters per minute. And that 2.5 is the slope of your equation. Since it's negative, you know that the line is going to be decreasing. What does W of T represent? And is it the input or the output of this function? And so W of T is just the amount of water left in the tank. It is how we calculate how much water is in that tank and how we can figure that out. And T is the time in minutes. So that means that T is the input, and we know that because it's in the parentheses after the name of the function. And so T is your input, and W of T is the output, and that's what you get as your answer. So then you were asked to sketch a graph of the function and make sure that you labeled the points. So I had you plot 2 points, and those were your y-intercept at 0, 80, because we knew that we started with 80 liters of water in the tank. And so that is our y-intercept. And then I gave you a hint that after 32 minutes, there was 0 water left in the tank. And so that was your hint that your x-intercept should have been at 32, 0. So hopefully you got those, and then you use the line tool just to connect those 2 points. And you can see that your line is decreasing. All right, so let's look at this problem a little bit more in detail. So this tank of water had 80 liters, and the function W represents the relationship here. And so we're using the same equation that we had before. So how much water will be in the tank after 13 minutes? So what we're going to do, you could either look at that graph you just created, or we could use our function. And we need 13 minutes, and that's going to be our time. So instead of T in the function, I'm going to put 13 to evaluate our expression here. On the other side, we would have 80 minus 2.5, and instead of T, I would input 13. Okay, and from there, we can just solve that simple equation here. So we have W of 13, because that does not change. It's just the name of our function and our input. And so we start with multiplication. So negative 2.5 times 13 would give us, 32.5, and then we do that subtraction, 80 minus 32.5, and get 47.5. So W of 13 tells us that at 13 minutes, the tank of water had 47.5 liters inside. Okay, so what if we didn't want to know how many liters of water? What if we already knew that? And we wanted to know at what time the tank would have a specific number of water in it. Like number 3, we're going to try to figure out what time our tank would have 5 liters. Well, this expression and equation that we have right now, this function allows us to input the time, but we need to rearrange that so that we can input the liters instead of the time. And we can do that by writing the inverse function. So we're going to make an inverse function of W. So let's start with our function. We have W of t equals 80 minus 2.5 t. So instead of having this solve for the output, we need to rearrange this and solve for t. And so we're going to just switch the W of t and the negative 2.5 t. So I'm going to add 2.5 t to both sides. And that will give me 2.5 t plus W of t equals 80. Okay, and that way it keeps my t variable positive instead of negative. And so then I need to subtract W of t to move it to the other side for both sides. Okay, move up here. So when I do that, I now have 2.5 t equals 80 minus W of t. Okay, and we're almost done. We don't want 2.5 t, so we have to undo that multiplication there. So you have to divide both sides by 2.5. Because what you do to one side, you have to do to the other side. That will cancel those out. And so your final inverse function will be t equals 80 minus W of t divided by 2.5. And so that gives us our inverse function that we can use to find out how many minutes it will take to get 5 liters of water. And so we can plug 5 liters in for W of t because that is the variable of this function that tells us how much water is left in the tank. So we'll replace that, t equals 80 minus, and instead of W of t, we're going to put 5 divided by 2.5. Okay, and so you just have 80 minus 5, so we're going to keep solving this down. And 80 minus 5 is 75, and we need to divide that by 2.5. And so t equals 30 minutes. And so we would get 30 minutes as our time that the tank of water would have 5 liters left. Okay. The next question I want you to think about a little bit is how would the graph of the inverse function of W compare to the graph of W? So we started out with our original equation, and it's W of t equals 80 minus 2.5 t, and we ended up with...
Teachers, if you have a 10 o'clock appointment for your shot, please go ahead and make your...
And we have our inverse function, which is t equals 80 minus W of t divided by 2.5. So how do these two graphs compare? Well, let's look at them. So our graphs, which pop up here, we have our input on the first graph is our time, and our output is the amount of water left in the tank. And when we take that and we write the inverse of that function, those variables switch. So our input of time becomes the output on the inverse function. And our output of amount of water in the tank becomes our input. So our variables that we have on our X and Y axis are just reversed, but the data on the graph stays the same. So it doesn't matter if we're looking for 5 minutes or 30 minutes. So at 30 minutes, we knew that there were 5 liters. So at 30 minutes on the first one, we have 5 liters of water in the tank. So on this one, if we looked at 5 liters in the tank, we would see that it is also at 30 minutes. So your inverse function is just a reverse of what your input and output were in the original equation if you rearrange it correctly. And it helps us find what we're looking for a little bit faster than having to rearrange that equation and solve every single time.